Hi everyone. Today I am going to describe how to draw a formula for an alkane. In this question, we are going to draw the expanded, condensed structural and the line angle formula for pentane. Okay, let's analyze the problem. Do we know the molecule that we are going to draw the structure? Yes, it is given. It is the pentane. So what do we need to draw? We need to draw the expanded structure and the condensed structure and the line angle formula for pentane. Okay, so for the expanded and the condensed structural, we need the carbon chain, and for the line angle formula, we gonna draw the carbon chain in the form of a zigzag line. Okay, so we start the drawing of the structure by drawing the carbon chain. So what is this molecule? It is pentane. The molecule of pentane should have 5 carbon atoms in a continuous chain. In the continuous chain or in the main chain, there should be 5 carbon atoms for the molecule of pentane. Okay. I have drawn this continuous structure for the pentane. 1, 2, 3, 4, 5. There are 5 carbon atoms are in this continuous chain of this for this structure for pentane. Next, I am going to expand this structure by adding the hydrogen atoms using the single bonds to each of these carbon atoms. A carbon atom in an alkane should have 4 single bonds. Okay, so the atoms should corner carbon atoms should get 3 hydrogens, and these the carbons inside the chain should get 2 hydrogen atoms for each middle carbons. Okay, here I have added 3 hydrogen atoms for the end carbons. Okay, and there are 2 hydrogen atoms have been added to the middle or inside carbons of this carbon chain. If you count the number of the single bonds on one carbon atom, there should be 4 single bonds for each carbon in this pentane molecule. And this is the expanded structural formula for the pentane molecule. Next, I'm going to draw the condensed structural formula for this pentane. Now, I'm going to combine the hydrogen atoms with each carbon atom. So, this whole structure, so there are 3 hydrogens are attached to this carbon atom. So, I'm going to write it as C for the carbon, H for the hydrogen, and the subscripted 3. That is for these 3 or the number of hydrogens which are on that carbon. So this is a CH3, and the next carbon has 2 hydrogens on it. So it is CH subscripted 2. So it is CH2. Next, again CH2. Again CH2, and the end has again 3 hydrogens on that carbon. So that is going to be CH3. CH3, CH2, 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 CH3 is the condensed structural formula for pentane. Next, we'll draw the line angle structural formula for this pentane. Now, I'm going to draw this structure as in zigzag line, which the ends and corners represents the carbon atoms. So this is end and these are ends and these are corners. So each end and corner represent a carbon atom. CH3 here, CH2 here, CH2, CH2 and CH3. This zigzag line structure is the line angle structural formula for pentane. If you count these ends and corners, altogether we should have five. One, two, three, four, five. So we have drawn the expanded structure and the condensed structure and the line angle structure for pentane. Okay, now we are going to draw the um, the structural formulas for C4H10. What is the C4H10? That is the butane. Okay, so first I'm going to draw the expanded structure. So I'm going to draw the continuous carbon chain. How many carbons should I include in the continuous chain? Yes, there are four. So I should include four carbons. One connected with a single bond, one, two, three, and four. Next, I'm going to add the hydrogens on it. Okay, so the end carbons get three hydrogens and the middle carbons get two hydrogens on each. This is the expanded structure for the butane or C4H10. Now I'm going to draw the condensed structure. So then I'll write this as a whole unit. This is CH3, CH2, CH2, CH3. That is the condensed structure for butane or C4H10. Next, I'm going to draw the line angle formula. So, the ends and the corners should include only, altogether we should need only four because there are only four carbons in this molecule. One, two, three. One, two, three, four. That is the line angle formula for C4H10. If you count the number of carbons, there should be only four. And if you count the number of hydrogen, there should be only 10 hydrogens.